In example 4, we're asked to use a calculator to find how many times the graph of y equals x squared minus 3 plus sine quantity 2x minus 1 changes concavity on the interval from 0 to 2 pi. First of all, you might think that if you just graph this function and look at it, you might be able to tell, but the problem is the changes are so slight, it's difficult to actually see where it's concave up and where it's concave down. And so this really is a function that begs for some sort of analytical treatment. Now, this is also a great opportunity to look at shortcuts on the graphing calculator for differentiating the function and plotting those derivatives and finding the zeros of a function. And since I don't have a graphing calculator emulator installed on my computer, I can't really show you how to do that in a video at this time. So what I've done instead is I've typed up step-by-step instructions for treating this problem using the graphing calculator, and I've included that as a PDF file on Google Classroom in this section. So please download that file and follow along with your graphing calculator to solve this equation. Now, just for practice, we can go ahead and take the first derivative. So y prime is 2x plus the derivative of sine is cosine 2x minus 1, and the derivative of 2x is 2, so we bring that out front. And then we will take the second derivative. And so the derivative of 2x is 2 plus the derivative of cosine is negative sine, so minus sine of 2x minus 1. The derivative of 2x is 2 times the 2 that was already out front gives us a 4. And so this is my second derivative, 2 minus 4 sine 2x minus 1. Now what we need to do to find critical values is set this equal to 0 and solve it for x on the interval from 0 to 2 pi. And we could do this using the unit circle. It is equivalent to solving the equation sine 2x minus 1 equals 1/2. And so take every angle between 0 and 2 pi where sine is equal to 1/2 and set 2x minus 1 equal to that angle and then solve. And we end up with some very complex exact answers, but doing this analytically on the graphing calculator, I was able to find the following solutions rounded to 3 decimal places, which is less time consuming and a faster method, especially for the AP exam. So x is an element of the set 0.7618, comma 1.8090, comma 3.9034, comma 4.9505. So I encourage you to download the PDF and work through that step by step using your graphing calculator and see if you can come up with these same solutions. We may possibly do this in class as a class activity. Certainly we can answer questions about it if you guys still have questions. Just let me know.